Hello everyone. In today's video, we are going to learn about representing knowledge in an uncertain domain, Bayesian networks. Introduction. Bayesian network is a data structure to represent an uncertain knowledge or domain. It is a directed acyclic graph whose nodes correspond to random variables. Each node is annotated with conditional probability distribution for the node given its parents. Bayesian networks, often abbreviated as BayesNet, were called belief networks in the 1980s and 1990s. The full specification is as follows. Each node corresponds to a random variable which may be discrete or continuous. Directed links or arrows connects pair of nodes. If there is an arrow from node X to node Y, X is said to be a parent of Y. The graph has no directed cycles and hence it is a directed acyclic graph or DAG. Each node xi has associated probability information theta of xi given parents of xi that quantifies the effects of the parents on the node using a finite number of parameters. Topology of Bayesian network. The set of nodes and links specifies the conditional independence relationships that hold in the domain. The intuitive meaning of the arrow is typically that X has a direct influence on Y, which suggests that causes should parents of fx. It is usually easy for the domain expert to decide which relationships exist in the domain. Once the topology is laid out, local probability information is provided for each node or variable in the form of conditional probability given its probability. The full joint distribution for all the variables is defined by the topology and the local probability information, a simple Bayesian network in which weather is independent of the other three variables. Toothache and catch are conditionally independent given cavity. This is indicated by the absence of link between toothache and catch. It also indicates that cavity is the direct cause of toothache and catch, whereas no direct causal relationship exists between toothache and catch. Let's discuss another example as to how to create a Bayesian network. Assume your house has an alarm system against burglary. You live in the seismically active area, and the alarm system can get occasionally set off by an earthquake. You have two neighbors, Mary and John, who do not know each other. If they hear the alarm, they call you, but this is not guaranteed. We want to represent the probability distribution of events burglary, earthquake, alarm, Mary calls, and John calls. Directed acyclic graph. Nodes, random variables, burglary, earthquake, alarm, Mary calls, and John calls. Links, direct causal dependencies between variables. The chance of alarm is influenced by earthquake. The chance of John calling is affected by the alarm. Local conditional distributions relate variables and their parents. The local probability information attached to each node takes the form of a conditional probability table. Each row in the CPT contains the conditional probability of each node value for conditioning case. A conditioning case is just the possible combination of values for the parent nodes. Each row must sum to 1 because the entries represent an exhaustive set of cases for the variable. This diagram is used to represent it. Bayesian network is the representation of the joint probability distribution. Assume that the Bayes net contains n variables x1 till xn. The generic entry in the joint probability distribution is given by P of x1 to xn. Bayes net define each entry as follows: P of x1 to xn is equal to summation of P of xi given parents of xi, where I takes values from 1 to infinity. To illustrate the example, we can calculate the probability that the alarm has sounded, but neither a burglary nor an earthquake has occurred, and both John and Mary call. We would simply multiply the relevant entries from the local conditional distributions. We get the answer as 0.000628. In conclusion, effective strategies for navigating uncertainty in knowledge representation are critical in complex domains. Embracing adaptive techniques, probabilistic reasoning, and collaborative approach can enhance representation and decision making. Thank you.